Good. All right. So I know. Wait. So y equals tan x on 2.
Mm-hmm.
So that means it's going to be half of tan in the space of 2 pi.
Oh, okay. So remember I told you that rule that
It doesn't apply, does it? No.
No, wait, but it does, but there's just a slight tweak. Like basically the period of a normal cos and sine is 2 pi, right?
Yeah.
But in this case, the period of a tan is actually pi. That's the normal period of a tan curve.
Right, okay.
Right. So what that means is that you can fit half in pi, not 2 pi.
Okay.
Because the domain normally for tan is pi anyway. Does that make sense?
Yeah, no, I get it.
That's just the slight adjustment.
Okay.
All right. Well, look, let's start with the original.
Okay.
What does the original tan function look like?
I always remember that the x-intercept as a pi is at pi, and then it goes up there, and there's a asymptote at pi on 2.
Yeah.
And 3 pi on 2, and then it just continues.
Yes, good.
So 2 pi, blah, blah, blah.
Yeah, cool. Let's pop it in. So we're drawing the normal one first. So like you said, and I'm just going to mark pi, 2 pi, whatever. And then there's an asymptote at pi on 2, and at 3 pi on 2. So boom, boom. And then it goes like so. And then it's just symmetrical really about that point. Yeah, cool. Just like so. Yeah. Let's draw the negative asymptote as well. Like the other side of the other one. So like
I know that's
Yeah. So what that means is now, so the period of this is pi on n, and n is a half. So the period of this is 2 pi of this one.
Right.
The period of this one is pi, because we already established that the normal period of tan is pi. And this one can only fit half in pi, which means the period is 2 pi. It needs double the time to fit the whole thing.
Yeah.
So what you now have to do is change your asymptotes. So instead of your asymptotes being at pi on 2,
it's going to be at pi and 2 pi. I mean, not pi, 0 and 2 pi.
But the thing about tan is that there's no asymptote at 0. All right, so yeah, the asymptote at pi on 2 is now at pi. And this asymptote that was at negative pi on 2 is now at negative pi. Oops, sorry.
Right, which is given in the question, because that's the domain.
Yeah, so see how now the asymptotes, the distance between the asymptotes is 2 pi, because it's negative pi on one end and pi on the other end.
Oh, I got you.
And now it's just like that.
Right. So did you start, hang on, wait, negative pi. Did you start like from the y-axis and then moved that way?
Yeah, that's right, moved outwards. Yeah. Because we're stretching it, because we can only fit half within the normal time. And so the period is now doubled.
Yeah, okay. That makes more sense. But the domain was 3 pi, wasn't it? Yeah.
Yeah, the domain was negative pi.
So now I do. Okay, so that's why, because we're fitting 2. Got you.
So where would the next asymptote be, do you think?
At 3 pi.
Yeah, exactly. Good.
It's actually a really pretty graph. Like, I quite like it.
That's good. Appreciate its uniqueness. So yeah. So between pi and negative pi and 3 pi, you can fit 2 tan x's on 2.
Right, okay.
Because,
the normal period for, what did you say? Tan was pi.
That's correct.
And now that's going to 2 pi.
That's correct, yeah.
Cool. Find the equation of the normal, pi minus pi 1. Find the equation of the normal to the graph. Y equals x on 2. So y equals tan x on 2. So we have to work out we have to do the derivative. So that's y correct. Dash is equal to, so what is tan equal? Sec squared. So that's 2 sec squared x on 2.
So you said 2 sec squared x. Now the coefficient of x is half, not 2. It's 1/2.
Yeah, but didn't you say it was...
Oh, that's for integration.
Are we going... Oh my God, I'm going backwards.
It's okay. So yes, so integration you do 1 on. Yep.
Yeah, so y dash... so it's just 1/2 sec squared x on 2.
Yeah, exactly. Beautiful.
Okay. All right, so that's that. And then what does x equal to?
Pi on 2.
Pi on 2. So we have 1/2 sec squared pi on 2 over 2. So we have 1/2 sec squared, and then so that's equals to pi on 4.
Yeah, that's right.
Yeah, and then sec pi on 4 is √2.
Yes, and but because it's sec squared.
Oh, so it's squared, so that it just equals 1/2 times 2.
Yeah.
Which equals 1.
Beautiful. So that's the gradient of what?
Tan x on 2, the original.
Oh, that's the gradient of the tangent, of the original at that point.
So it's -1 because it's
of normal.
Yeah.
Yeah, good.
So it's -1. So y minus 1. Oh no, we have to find the y-intercept.
Yeah.
Excuse me. All right, so tan... What do you say x was? X... No,
X
pi on 2
over
2. So tan pi on 4. And tan pi on 4 is 1.
That's correct.
So y is equal to 1.
Yeah, so the point is pi on 2 and 1.
Yeah, okay. So y minus y1 equals mx minus x1. The amount of times I've written out that equation is ridiculous. So y minus 1 equals -1 x minus pi on 2. Oh, that's nice.
It is. It's actually not bad.
Equals minus x plus pi on 2.
Yeah.
Y equals minus x plus pi on 2 plus 1.
Yeah, good. Beautiful.
Are we doing, should I just leave it in that form?
Yeah, we'll leave it in y equals mx plus b form, yeah. Okay. It didn't specify. You know, if it does specify, then do what the question says. But when it doesn't, do what you want.
As accurately as possible. Sketch the normal onto the same... That's not fair.
Showing the coordinates of points of intersection with the axes. So you have to graph this on that curve. And then you also make sure that you indicate the x and y intercepts of this normal. So first of all, this equation of the normal comes from the equation of the tangent because it's perpendicular to the tangent. And the tangent comes from the original equation, right? Because it's just a tangent at the point where x equals pi on 2. So if you go to your original curve and you find where x equals pi on 2, which is here, right?
Mm.
And you draw a tangent.
Hang on, so where is it? Pi on 2. So
yeah. And that's the point there on the curve. That's pi on 2. You draw a tangent to that line, to that point.
Mm-hmm.
That's the tangent, but the normal is perpendicular to that tangent. So then you draw a line that's perpendicular to that tangent.
Mm-hmm.
And that's your normal.
Right.
Does that make sense?
Mm-hmm.
And so now you just have to indicate, okay, well then what's the y-intercept and what's the x-intercept?
Okay. So that's... How
do you think you'd find that?
Hang on, that's pi on 2. So, we just do x and y is equal to 0.
Yeah, with the function of the normal, yeah.
So x is equal to pi on 2 plus 1.
Yep.
So x is equal to Alright, so what is it? Pi on 2 plus 1 equals 2.57. And then, hang on, y? I'll do it anyway. Plus pi on 2 plus 1. So x is equal to 0.
Yeah.
So y is... Oh, yeah, lol. It is the same. That's so cool. 2.57, blah, blah, blah.
Yeah.
So I just have to indicate 2.
Yeah, that's pi on 2 plus 1. Now, if you realize, so pi on 2 plus 1 you said was 2.7, was it?
2.57.
2.57. And you see how I've intercepted it here, but 2.57 is actually less than pi.
Yeah.
So my curve should have intercepted here.
Yeah, mine did.
Yeah, mine didn't. So, yeah, so that's what it should be really, but I got my angle wrong, so.
Yeah. So you always got to make sure that your graph is like
it makes logical sense.
Yeah. The circle, the radius of a circle is 3. What angle at the center? Sector, so the area is 18 centimeters squared. Yep. So area of a sector, A equals 1/2 R squared 0. So we're trying to work out, what was it? The angle, right? Okay, so 18 is equal to 1/2 times 9 times angle, or theta. So 18 over 1/2 times 9 is equal to theta.
Yeah.
So 18 over 4.5, and whatever that is equal to. Equals 4.
Yeah.
That was easy.
But that's in radians, isn't it?
Oh, right.
And the question asks for degrees. So.
Right. So from degrees, so it goes 4 times 180 over pi.
Yes, good.
Yes. So 4 times 180 over pi. So that's 229 degrees.
Yeah, to the nearest degree, that's correct.
Mm-hmm.
Good.
Change 2 degrees.
Yeah. Or I guess it always comes back to rereading the question before you move on to the next one. Just have a quick read, make sure you've answered every part of it. Yeah.
All right, sketching. I can sketch. So y equals -4 cos 2x.
Yep.
So pi on 2, pi 3, pi on 2, 2 pi. And what are we going up to? Oh, minus. Oh wait, so we're going up. It's 4, but it's going to be the other way.
Yeah, that's right. It's going to be flipped.
Okay. And it's 2, so there's going to be 2 in each thingy.
Yes.
So it's going to start at -4 and go now, and then go up like a hilly mountain. Right. Beautiful. All right. So.
Is that what you have?
Yeah.
I tried.
That's beautiful. So don't doubt yourself. Okay.
Let me fix that.
2 pi and 0 -4 cos 2x.
Ooh.
Okay. So now we have to, so -4 times 1/2. Wait, if it's minus cos, then it's going to be minus sine.
That's right, yeah. Because when you just integrate cos, you get positive, and so the negative will just give you a negative answer.
Yeah, okay. So that's so minus, what's -4 times 1/2? So is it -2 or just 2?
Well, it's -4 times 1/2, so it's -2.
Yeah, okay. So -2 sine 2x. Cool. So -2 sine 2 times 2 pi.
Yep.
Minus -2 sine 2 times 0. So that one's going to equal 0. So -2 sine. So that just becomes 4 pi.
Yeah. And what's 4 pi?
0.
Yeah, so what's the answer?
0.
Yeah. Cool. Why is that? Can you explain to me why the answer is 0?
like as in graph, like as in like on the
yes,
like,
on the graph.
Yeah.
Using the graph. What do you think?
Is it because we like? Is it because like the? I don't know how to explain it. Like this, I can't. Don't see my mouse. Like that hill is equal to that hill
this
as well.
This one here?
So, yeah, is equal to that.
This one?
Yeah, so they cancel out because we're not using absolute value.
Yes,
is that
good.
One?
That's correct. So basically, this integral over here just states that you're integrating this curve, because this is what we've drawn, between 0 and 2 pi.
Mm-hmm.
So what you're finding is this,
yeah,
and then you're finding this, and then you're finding this, right?
Yeah.
That's what that integral states. And so this hill is going to cancel with this hill.
Yeah.
And then these two little ones
will cancel with that one.
And cancel with that one. So that's why overall you get 0. So what you've done is you haven't found the area, you found the value.
Right. Okay.
Does that make sense? Because sometimes the question can ask you to find the area, sometimes they can ask you to find the value of the integral.
Right. Okay.
So if they're asking, because part B asks for the area, and so now you're like, yeah, I've got to split it up, right?
Ah, okay.
Yeah, that's the difference between A and B. A is asking for the value, B is asking for the area. Therefore, you have to absolute the negative areas, which means you have to split it up into separate.
Okay.
Yes.
Right. Okay. Yeah. Because I'm like, why is B? Yeah. Okay.
Yeah, exactly. Yeah.
So, alpha and beta. So now we're doing the same thing, but we have to split it.
That's correct. Yeah.
I don't want to. But okay. So we have. I'll do this. That's A1, I'll say. So S, I'll do from.
Wait, so what you're going to do is split from 0 to pi on 4, and then from pi on 4 to 3 pi on 4, and so forth that way, right? Until you get to 2 pi.
I was going to do.
Yeah.
The 3 pi on 4 to pi on 4 times 2 to make up for the other hill.
Yeah, this one here, yeah.
And then do like, what's that? 5 pi on 4 to that one, and then double that as well.
Yeah. So basically, in other words, one chunk, so this chunk over here between 0 and pi on 4, because of the symmetrical nature of it, this is the same thing as if we were to split this in half. So what you can look at this area as is, I'm going to call it half a hill. So how many half hills do you have in this? So you got one here, one here, one here. Yeah.
4, 5, 6, 7, 8.
8. So all you need to do is find the area of one half hill and times it by 8.
One half hill, I love it.
Instead of doing like 3 separate areas, just realize that there's a symmetrical nature of it. So you just have to times it by as many as there are.
Right. Okay. So we have 8 times S. What is it? Pi on 4 and 0.
Yeah.
And then let's see, minus 4 cos 2x.
Yeah. Good.
So that equals. What did I do it to? So minus 2 sine 2x. Pi on 4 and 0. So minus 2 sine 2 pi on 4. And then the other one would be 0. So it's just that one.
Yeah.
So it's minus 2.
Yeah.
Minus 2 sine pi on 2.
Yeah.
So minus 2 times, what's pi on 2? 1. So that equals minus 2 times 8, which equals minus 16.
Yes. Why is it a minus? You're like, oh my God, area, why is it a minus? Area should be positive. But then you look at your area and it's a curve.
So it's an absolute value.
Absolute it, yes.
Yes, so it equals 16 units squared.
That's the one.
Cool.
Beautiful.
Okay, that's good to know between evaluate and find the area of.
Yes, yeah. There's it's different, even though it's so similar. So now you see where the squared is, right?
Yeah.
Yeah.
So sine squared 2x. So is that going to equal sine bracket 2x squared?
Oh no, because the squared after the sine, so before the x, means that the whole thing is being squared. So what it means is that
okay, it's different. Yeah, it's different to the other one. So that equals sine 2x squared.
Yeah. So the other one was sine 2x squared, like in the context of this question, like that, and that means that only this is squared.
Yeah. Okay.
Yeah.
Hang on, let me write that down. Okay, so sine 2x squared is sine 2x squared, but then this one is sine squared 2x, which equals sine. Right, okay.
It's like when you have cos squared x. It's basically like you have cos x times cos x, so 2 lots of cos x.
Yeah. Okay, so then we move, so this is just the chain rule. So you go 2 times 2 cos 2x bracket sine 2x, and then it drops a power, so it's just 1. So it becomes 4 cos 2x sine 2x.
Good stuff.
Is that it? Do I just leave it as that?
Cool. Yeah, there's no way we can simplify it, so we'll leave it at that. Good.
Yay.
Good.
Oh, okay. Okay, so cos 1 minus x over 5.
Yeah.
Okay.
What do you think?
Well, you said it's... Do we flip it and put it out the front?
What are you going to flip and what are you going to put out the front?
I don't...
Oh, right, the coefficient of?
X.
X. But what is the coefficient of X? I'll give you a hint.
Okay, give me...
Rewrite what's in the brackets. Rewrite it into 2 separate fractions. Because there's 2 terms on the numerator, right? Split them into 2 separate fractions. So what I mean by that is cos of 1 over 5 minus x over 5, right?
Oh, right.
Just split it up, because it's the same thing.
Okay. So, so now do we do minus 1 over 5 out the... minus 5 out the front?
Yeah, that's right, because the coefficient of x is minus 1 on 5. And so 1 on minus 1 on 5 is minus 5. Good stuff,
Minus 5, and then what the primitive, so it's sine. And then do we just do the same thing? Or just do 1 minus x?
Yeah, we'll write it how it was originally,
Yeah, okay. Ah!
Let's see, that's it. See? These questions are like made to trick you. But you're not going to get tricked, are you? Because you know how to fix it.
Okay. Nope. All right, let me write that down on a sticky note. Next one. A slope at any point on the curve is given by... Oh, so it's a gradient.
Yes.
Oh, it's the same thing we did before. 3 sec squared 2x. Okay, so it's square. So it's 3 sec 2x squared.
All squared, yes.
Yes, all squared. Okay, so how do we find the primitive of this?
Do you remember, what do you get when you differentiate tan?
Sec
squared.
Yeah, so it's tan.
It's tan.
But there's... Okay.
But there's a what?
Oh, wait, no. Don't worry. Don't worry. 2 times 3 tan...
Hold on, because it's integrating. It's 1 on, remember? 1 on coefficient of x. Yep.
Yes, that's 1/2 times 3.
Yes.
Tan 2x. Yes. Good. Sorry, I got thrown off by the squared, but that's just what it is. That's
exactly.
Not
yeah, that's the function that you need. Yeah, that integrates.
So 3 on 2. tan 2x plus phi.
Good.
And then, so root 3 on 2 is equal to 3 on 2 tan 2 root pi on 3 plus phi. Okay, so root 3 on 2 equals 3 on 2. Okay, so tan pi on 6.
Tan
right?
2 pi on 3. Because 2 times pi on 3, yeah.
Yeah. 2 plus c root 3 over 2 equals.
So what's 2 on 3?
Okay. All right. Tan pi on 3 is root 3, right?
Yes.
But it's 2 pi on 3. So it's in the second quadrant. Yes. So it's a negative.
Good.
So
and how do you know that the acute angle is pi on 3?
Because it's just pi on, it's just pi on 3. I just ignore the 2. Because
it's pi minus 2 pi on 3 is pi on 3. That's how you know that's the acute angle in the second quadrant.
Yeah. Okay.
Yeah, that's it.
Yeah, okay. Plus c. Right. Okay. So root 3 on 2 is equal to, so minus 3 root 3 on 2 plus c.
Yeah.
So move this over. So root 3 on 2 plus 3 root 3 on 2. Oh, that's nice.
Good, yeah. And then
c.
Yeah.
So that's hang on, so 3. Oh, so that equals 4 root 3 on 2.
Yes.
Equals c. See, I forgot how to do, so
for a second.
I forgot how to collect like terms.
Can you simplify 4 root 3 on 2?
Yeah, you can.
What does it become?
2 root 3.
That's the one. Good. So c is 2 root 3. Yep.
So therefore, what did we work out? What did we?
Up here on the line.
What are we doing? Find the equation. Yeah. So 3 on 2 tan 2x plus 2 root 3.
Good stuff. Perfect.
Thank you. Yay.
Awesome. So it's worth 4 marks. I feel like it was more algebra that you had to work with than like the difficulty of the question, you know what I mean? Alrighty.
Pi and, is that pi on the top?
No, that's actually n.
Is it?
Yeah. So n just represents any integer. So it's just n.
Okay.
It could represent any number.
Great. 2 pi x. Okay. So we're going to have x plus, what are we doing? So 1 over 2 pi minus cos 2 pi x?
Yeah, good. So
is it? Oh, good.
Yes, it was minus 1 on 2 pi, is that what you said?
Yeah, so minus 1 over 2 pi cos 2 pi x.
Yeah, good stuff. Nice.
Yeah, the boys. And then, so n and 0. So do I just sub in n and 0? Like
That's correct. Yeah.
Right. Yeah. So n minus 1 over 2 pi cos 2 pi n minus, we're doing the same thing. 0 minus 1 over 2 pi cos 2 pi 0.
Yeah, good.
Right. So that becomes, so the second part becomes 0. Does it?
What's cos of 0?
Oh, 1.
Yeah, cos of 0 is 1.
Right, so it does become something.
Yeah, it does.
So n minus 1 over 2 pi and cos 2 pi n minus minus 1 over 2 pi.
Yeah.
And then cos is, so that's just 2 pi.
What is it?
Wait, hang on.
So you're doing this part here, the cos 2 pi n?
No, the next part. Because 2, wait.
Oh, this one here. So it's cos, so this is cos of 0.
Mm-hmm.
And cos of 0 is 1.
Yeah.
So this gets replaced with 1, not cos of 1.
So it's just that, okay.
Yeah.
What is it? N minus 1 over 2 pi minus cos 2 pi n plus 1 on 2 pi. So those 1 on 2 pi cancel, so it's n minus.
Oh, how do you know? Because they're not the same. They have the same coefficient, but this one has cos 2 pi n with it.
Oh! Oh no!
Oh no, what do we do?
Oh no.
Let's think. Let's think for a second. So, let's zoom out first. Hello.
Are we trying to work out n, or are we just simplifying still?
Well, we're still simplifying, but, so I told you from the beginning that n represents any integer. So n could represent 1, 0 for starters, 1, 2, 3, and whatnot. And the negatives as well.
Yeah.
So, I know it's got n, and like I said, n has an infinite number of values. But what if, regardless of the value of n, we still always got the same value?
Yeah.
So what I'm trying to say is, all right, I'm just going to take this out of the equation for a second. I'm going to pop it here. So cos 2 pi n, okay? Like I said, n can be anything. Let's start when n equals 0. When n equals 0, we get cos 2 pi times 0, we get cos 0.
Yep.
Cos 0 is 1. Okay. So when n equals 0, cos 2 pi n is 1 because n is 0.
Mm-hmm.
Now let's try when n equals 1. When n equals 1, cos of 2 pi times 1 is 2 pi.
Which equals 1.
And cos 2 pi is what? Did you say? 1. Okay. Let's try negative 1. When n equals negative 1, let's sub in negative 1. So cos, so you sub in negative 1 here, you get cos of negative 2 pi.
Mm-hmm.
And that becomes?
1.
1. Let's try 2. The last one, I promise.
No.
Cos of 2 pi times 2 is 4 pi.
Which is just 1.
Which is 1. So do you realize a pattern? So regardless of the value of n, cos of 2 pi n is always 1.
Right.
So what that means is that this can be rewritten as just 1.
Right, okay. So this equals 1.
It's amazing, isn't it? And that's why this question is worth 3 marks. Because you had to have realized that. And the only reason I know that is because of prior practice, right? I wouldn't have picked that up if this was the first time I've done it, you know?
Yeah.
But yeah, keep that in the back of your mind.
Okay, so cos 2 pi n is equal to 1.
Yes.
Interesting.
I know, it's pretty amazing.
Yeah. Right, okay. So that just leaves us with n minus 1 over 2 pi times 1.
Times 1. Yeah.
Yep. Plus 1 over 2 pi. See, they do cancel.
Yeah, see, I didn't want to say yes.
Yeah.
Until we got that. You know what I mean?
No.
Yeah.
And then, so it's just n.
Yeah. Answer is n. That's it. Answer is n. Done.